So this is a set of data where applying a simple linear model isn't going to work because the data actually has a curve. And so you need to do some transformation of the data. So here we have some data for the pH of steer carcasses measured at 5 times after slaughter. So what you've got is pairs that after 1 hour, 2 hours, 4 hours, 6 hours and 8 hours. And you've got their pH, so their acidity of their tissues. As meat cures, it becomes more acidic. So first thing you need to do is plot it, so you can see that as the steer carcass data on their acidity is not linear. You can see that it has a curve on it. If you take the logarithm of the data, then you'll end up with a linear relationship. Now, exactly what transformation you need to do to get your data to be linear, that is a bit of trial and error. So you can try reciprocals, you can try logarithms, you can go to more complicated functions. So there's almost always a transformation that can make any shape of curve into a linear curve. So once you've got the idea that a logarithm will work, you need to do the transformation. So within SPSS, what you can do is do compute variable. So we've got two variables, which are the time and the pH. We want to click on compute variable. We then want to create a new column of data, so the target variable, which is going to be called log natural of time, and it's going to be log natural of time. So it's just the logarithm of time. You could do ln, which is natural logs, or you could do log, which is log to base 10. It doesn't really make any difference. So you just put in a formula exactly as you would in Excel when we did binomial or other functions, and you can calculate the natural logarithm. Then when you plot the computed variable, you can see that now you have a nice straight line. If you'd used log 10, you'd have got exactly the same effect. It's just the scale along the x-axis would have been slightly different. When looking at the output from SPSS in terms of the correlations, the correlation for the untransformed data and the transformed data between time and pH and log time and pH, the difference is very small. So you're talking 0.966 against 0.991. Both of them have a very high correlation to start with. So you couldn't tell just by looking at correlations whether the log model was better than the linear, than the unlogged model. Looking at the regression coefficients, the constant is about the same in both of them. The t-values, they're significant for both of the models and for both the gradient and the intercept. The confidence intervals are good, everything looks fine. So with time you've got a gradient of minus 0.209, with log time you've got a gradient of minus 0.726. You've got a confidence interval of minus 0.805 to minus 0.646 compared to minus 0.254 to minus 0.163. In both these models, there's still no evidence, no way you could distinguish between using the time model or using the log time model. But if you do the residuals, when you look at the residual plot for the untransformed data, there is a clear U-shape in the data. But when I do the residual plot for the transformed data, there's a random scatter across the ranges of X. There's no pattern in it whatsoever. So the only way you could tell that you actually need to use the transformation is because of the residual plot.